Last lesson we asked which features matter to the model overall. Now we zoom all the way into a single person, and one single decision. Why did the model flag this exact applicant? Let's make it explain itself. These are two different questions. Feature importance was global, about the whole model, on average. Today's question is local, about one specific prediction. Global tells you the model usually cares about debt. Local tells you why this person, in particular, was flagged. Meet our applicant. Their income is low, their existing debt is high, their credit history is long, and the loan they want is small. The model predicts, likely to default. But we want more than a verdict. We want the reasons. We start at the base value, the model's average prediction across everyone, before looking at this person at all. Think of it as the default starting point. From here, each of this applicant's features will nudge the prediction one way or the other. Now the pushes. This applicant's high debt shoves the prediction hard toward default. Their low income pushes it further that way too. But their long credit history pulls back towards safe, and the small loan nudges gently back as well. Add every push and pull to the base value, and you land at the final prediction. The forces toward default clearly won. And here's the beautiful part. Those contributions add up exactly to the model's output. Nothing is hidden. So now we can say it in plain words. This applicant was flagged as high risk, driven mostly by their high debt and low income, despite a helpful long credit history. That is a real explanation a person can understand, and even challenge. Why does this matter so much? For fairness and trust. If someone is denied a loan, they deserve to know why. Regulators may even require it. And it helps us catch a model that's leaning on something it shouldn't. The most popular tool for this is called SHAP. You wrap your fitted model in a SHAP explainer, ask it for the values of one prediction, and it hands back each feature's push. It works with the tree and boosting models we built in this very module. So, feature importance explains the model overall, while a local explanation shows why one prediction came out the way it did, each feature pushing from a base value to the final answer. And that completes Module 6. You now know a whole family of classical algorithms, how they work, how to choose between them, and how to explain them. Next up, learning without any labels at all. Great work!